We need to talk about what's hunting us. Not hunting in the way predators hunt prey on Earth, not with intention or awareness or hunger, but hunting nonetheless, in the cold mathematical sense of trajectories intersecting, of massive objects moving through space on paths we cannot see, paths that might lead directly to us. Right now, as you listen to these words, there could be a black hole moving through our galaxy, not orbiting peacefully at a galactic centre where we can track it, where we can map its position and predict its behaviour. A rogue black hole, untethered, wandering, moving at hundreds of kilometres per second through the darkness between stars, and we would have no way of knowing it's there until it's far too late. This isn't science fiction. This is astrophysics. We know rogue black holes exist. We know they're out there, scattered through the Milky Way, invisible predators drifting through the cosmic ocean. What we don't know is where they are. What we can't predict is when one might pass close enough to our solar system to change everything. Let's understand what we're dealing with. Let's map the nightmare before we learn to live with it. A black hole is a region of space-time where gravity has become so intense that nothing, not even light, can escape. The escape velocity at the event horizon exceeds the speed of light, which means anything that crosses that boundary is gone, consumed, added to the black hole's mass and forever cut off from the rest of the universe. We're used to thinking of black holes as stationary objects, anchored at the centres of galaxies, slowly feeding on the matter around them. Sagittarius A star, the supermassive black hole at the centre of our Milky Way, sits there like a cosmic anchor, 4 million times the mass of our Sun, holding the galaxy together with its gravity. But not all black holes are so accommodating. Not all of them stay where we can see them. When massive stars die, when they exhaust their fuel and collapse, they can form stellar mass black holes, typically between 5 and 50 times the mass of the Sun, compressed into a region smaller than a city. These black holes are born in supernovae, violent explosions that can kick the newly formed black hole away from its birthplace at speeds of hundreds or even thousands of kilometres per second. That kick is called a natal kick, and it happens because supernovae aren't perfectly symmetrical. When the star explodes, if slightly more matter is ejected in one direction than another, conservation of momentum pushes the remnant black hole in the opposite direction, like a rocket but powered by stellar death. Most of these kicked black holes remain in orbit around the galaxy, following predictable paths. But some, the ones that received particularly violent kicks, or the ones that underwent close encounters with other massive objects, can be ejected entirely from their home regions. They become rogues, wanderers, objects, with no fixed address, no orbital stability, just momentum carrying them through the galaxy on trajectories we cannot predict because we cannot see them. How many rogue black holes are out there? Conservative estimates suggest there could be tens of millions of stellar mass black holes in the Milky Way alone. Most are in predictable orbits, but a significant fraction, perhaps millions, could be rogues, unbound, moving through the galaxy like bullets through fog, invisible until they interact with something. And here's the truly unsettling part. We can only detect black holes when they're feeding, when they're pulling matter into accretion disks that heat up and emit X-rays. A rogue black hole moving through empty space, far from any stars or gas clouds, is completely invisible. No light, no radiation, no signal whatsoever. Just gravity, pure and silent, warping space-time as it passes. Imagine one is approaching our solar system right now. 3 solar masses compressed into a sphere, 30 kilometers across, moving at 400 kilometers per second. It's still light years away, but it's coming. In 10,000 years, it will pass within a few hundred astronomical units of the Sun. Not close by cosmic standards, but close enough. What happens? At first, nothing we'd notice. The black hole is too far away, its gravity too dilute at that distance to significantly affect Earth's orbit. But it doesn't need to hit us directly to destroy us. It just needs to pass close enough to the outer solar system to perturb the orbits of objects in the Oort Cloud, The Oort Cloud is a spherical shell of icy bodies surrounding our solar system, extending halfway to the nearest star. Trillions of comets, most no larger than mountains, held in delicate orbits by the sun's gravity. They've been there since the solar system formed, frozen and dormant, waiting. The rogue black hole passes through the outer regions of the Oort Cloud, and its gravity tugs on these icy bodies, not violently, not dramatically, just enough to change their orbits slightly, to send some of them falling inward toward the sun. Over the next million years, Earth is bombarded, not all at once, not in a single apocalyptic impact, but steadily, relentlessly, far more frequently than the normal background rate of comet impacts. Every few centuries, a mountain-sized chunk of ice and rock slams into Earth at 50 kilometers per second. Each impact releases the energy of millions of nuclear weapons. The atmosphere ignites, tsunamis circle the globe, ecosystems collapse, and just as life begins to recover, just as the survivors start to rebuild, another comet arrives. This continues for 1 million years, maybe longer, until the perturbed comets have all either impacted something or settled into new orbits. By then, Earth is unrecognizable. The biosphere has been reset multiple times. Whatever civilizations existed are ash and myth. And the black hole? It's long gone, continuing its journey through the galaxy, unaware and uncaring that it just sterilized a world. This is the threat of rogue black holes. Not direct collision, the odds of that are astronomically small, but gravitational perturbation. The ability to destabilize entire regions of space just by passing through, sending debris cascading inward, turning stable systems into shooting galleries. We wouldn't see it coming. We have no way to detect a rogue black hole unless it passes close enough to a star or gas cloud to create visible effects. By the time we noticed the increase in comet impacts, by the time we realized the Oort Cloud had been disturbed, the black hole would be tens of thousands of years away, beyond any possibility of study or tracking. We'd be left with the consequences, with no clear understanding of the cause, watching our sky fill with more and more long-period comets, each one a potential extinction event, and we'd have no way to stop them all. Let's make this more immediate. Let's bring the rogue black hole closer. Imagine it passes not through the Oort Cloud, but through the inner solar system. Still not a direct hit on Earth, but close, within Mars's orbit. Within the asteroid belt, the asteroids, those rocky remnants from the solar system's formation, have been in stable orbits for billions of years. The black hole's gravity reaches into the belt and stirs it like a spoon in soup. Thousands of asteroids have their orbits changed. Some are ejected entirely from the solar system. Others are sent tumbling inward. Earth now faces a bombardment from the asteroid belt. Not comets taking millennia to arrive, but asteroids arriving within years or decades. We'd see them coming, would have time to prepare, but preparing for asteroid impacts is extraordinarily difficult. We can deflect a single asteroid if we detect it early enough, if we have years of warning, if we're willing to dedicate enormous resources to the effort. But dozens of asteroids, hundreds, all arriving within a human lifetime, all requiring deflection, or evacuation, or simply acceptance of impact. We couldn't save everyone. We couldn't protect every city. We'd have to make choices about what to preserve and what to abandon, and those choices would tear civilization apart long before the asteroids finish the job. The black hole passes. It moves on, indifferent. It leaves behind a solar system in chaos, planets with altered orbits, moons displaced, asteroid belts scattered. And Earth, if Earth survives, would spend millions of years recovering, waiting for the orbits to stabilize, hoping no more large impacts are coming. This has probably happened before, you know. Earth has experienced periods of heavy bombardment. The late heavy bombardment, 4 billion years ago, when the inner solar system was pummeled by asteroids and comets. We've attributed it to the migration of the giant planets, to gravitational resonances that destabilized the early asteroid belt. But What if some of those bombardment periods were caused by rogue black holes passing through? What if the solar system has been disturbed multiple times over its history by invisible predators we had no way to detect? We wouldn't know. We couldn't know. The black hole would have passed billions of years ago, and all we'd have is the geological record of impacts, of mass extinctions, of sudden catastrophic changes in Earth's environment. The predators have been here before. They might come again. Now let's go darker. Let's talk about what happens if a rogue black hole doesn't just pass near our solar system, but passes near Earth itself. The probability is vanishingly small. Space is vast, and even a rogue black hole moving through the galaxy is unlikely to pass within Earth's orbit by sheer chance. But unlikely isn't impossible, and given enough time, given enough rogue black holes wandering the galaxy, even unlikely events eventually occur. So imagine a rogue black hole, 10 solar, masses, passes within 1 astronomical unit of Earth. That's the distance from Earth to the Sun. Close by cosmic standards. Terrifyingly close. We detect it, finally. As it approaches the inner solar system, as it passes near enough to the Sun or other planets, we'd see the gravitational lensing, the way its mass bends light from background stars. We'd calculate its trajectory, and we'd realise with absolute horror that it's going to pass near Earth. How near? Let's say half an astronomical unit. 75 million kilometres. Still far by human standards, but close enough for the black hole's gravity to be significant. Earth's orbit would change. Not dramatically, not enough to send us spiralling into the Sun or out into the cold, but enough. Enough to alter our distance from the Sun, to change the amount of solar radiation we receive, to trigger climate shifts that would take centuries or millennia to unfold. The planet would experience tidal forces as the black hole's gravity pulls more strongly on one side than the other. Nothing like the tides from the moon. The black hole is too far for that. But measurable, detectable, enough to stress Earth's crust, to trigger earthquakes along fault lines, to wake dormant volcanoes. And the psychological impact. Knowing that a black hole, an object from which nothing can escape, has passed near enough to touch us with its gravity. Knowing that if it had been just a bit closer, just a bit more massive, just on a slightly different trajectory, it could have torn our planet apart or pulled us into a decaying orbit. We'd survive this encounter. Probably. Earth is resilient, and a black hole passing at half an AU wouldn't destroy the planet, but it would mark us. We'd measure the changes in our orbit, in our climate, in our seismic activity, and we'd know. We were hunted. We were prey. And we survived only because the predator's path took it just far enough away. The black hole would continue on, unaware it had just changed the course of a civilization, and we'd be left watching the sky, wondering when the next one would come, wondering if next time we'd be so lucky. Let's talk about detection now, because that's the key question. Can we see these things coming? The answer is sometimes, maybe, if we're lucky. Gravitational microlensing is our best tool for detecting rogue black holes. When a massive object passes between us and a background star, its gravity bends the star's light, causing the star to brighten temporarily. By monitoring millions of stars and watching for these brightening events, we can detect massive objects that don't emit light themselves. We found planets this way, we found stellar mass objects, and occasionally we've found what might be rogue black holes, massive objects with no visible counterpart, betrayed only by the way they bend light. But microlensing only works if the black hole passes directly between us and a star we're monitoring. If it's moving through empty regions of the sky, if there are no background stars in our line of sight, we won't see it. And even when we do detect a microlensing event, we get only a brief snapshot. A few days or weeks of data as the object crosses our line of sight, and then it's gone, and we have no way to track its future trajectory. We're essentially watching for shadows in a dark room by waiting for them to pass in front of a flashlight. It works, but it's hardly comprehensive. There are proposals for better detection systems, networks of gravitational wave detectors that could pick up the space-time ripples caused by black holes moving through dense regions of the galaxy. Surveys that would monitor the entire sky continuously, looking for any anomalous gravitational effects. Early warning systems that might give us decades or centuries of notice if a rogue black hole is heading our way. But these are proposals, projects that would require international cooperation, enormous funding, decades of development. We haven't built them yet. We might not build them at all. And even if we do, they won't be perfect. Space is too vast, black holes too small, the possible trajectories too numerous. We will miss some, maybe most, and one of the ones we miss might be heading toward us right now. Here's what keeps astronomers awake at night. We don't know how many rogue black holes there are. Our estimates range from hundreds of thousands to hundreds of millions just in our galaxy. That uncertainty spans 3 orders of magnitude. We could be off by a factor of 1,000 in either direction. If there are only a few 100,000, the odds of one passing near our solar system in the next million years are small. We're probably safe. Probably. If there are hundreds of millions, the odds shift. It becomes not a question of if, but when, and when might be sooner than we think. We're flying blind through a shooting gallery, and we don't know how many bullets are in the air. Let's go deeper into the horror. Let's talk about intermediate mass black holes, the ones we barely understand, the ones that might be lurking in greater numbers than we've imagined. Stellar mass black holes, the ones formed from collapsing stars, max out at maybe 50 or 100 solar masses. Supermassive black holes, the ones at galactic centres, are millions or billions of solar masses, but there's a gap. A mysterious gap between hundreds and millions of solar masses where we've found very few black holes. This gap is called the intermediate mass black hole problem, and it's been haunting astrophysicists for decades. We have theoretical reasons to think these black holes should exist. Simulations suggest they could form from the collision of stellar mass black holes or from the direct collapse of massive gas clouds in the early universe, but we've barely detected any. Where are they? One possibility, one deeply unsettling possibility, is that they're wandering the galaxy as rogues, too massive to have been kicked away by supernovae the way stellar mass black holes are, but not massive enough to be anchored at galactic centres. They could be drifting through the Milky Way, hundreds or thousands of solar masses each, completely invisible, and we'd have almost no way to detect them unless they passed close to something we're monitoring. An intermediate mass black hole passing through our solar system would be catastrophic in ways a stellar mass black hole wouldn't be. Its gravity would be so strong that it could tear planets from their orbits, could scatter the solar system like billiard balls, could pull Earth itself into a trajectory that sends us into the sun or out into interstellar space. We wouldn't survive, not as a species, not as a planet. Earth would be destroyed, if not by direct impact, then by being pulled into an orbit incompatible with life. And it would happen over decades or centuries, slow enough that we'd watch it coming, fast enough that we couldn't do anything to stop it. How many intermediate mass black holes are out there? We don't know. Could be dozens, could be thousands. They're ghosts in our models, predicted but unobserved, and the fact that we haven't seen them doesn't mean they aren't there. It just means we haven't looked in the right way, or they haven't passed close enough to anything that would reveal their presence. They could be everywhere. They could be nowhere. We're guessing. And in that uncertainty, in that vast unknown, there's room for existential terror. Because if intermediate mass black holes are common, if they're wandering the galaxy in numbers we haven't anticipated, then we're living in a cosmic minefield. Every year that passes without catastrophe is just luck. Just probability working in our favour for one more orbit around the Sun. Eventually probability catches up. Let me tell you about HVS3. It's a star, a hypervelocity star moving through the Milky Way at 700 kilometres per second. That's fast enough to escape the galaxy entirely, to become an intergalactic wanderer. We know what accelerated it. A close encounter with Sagittarius A star, the supermassive black hole at the galactic centre. The star was once part of a binary system, It and its companion were orbiting each other peacefully until they wandered too close to the black hole. The black hole's gravity ripped the binary apart, captured one star, and flung the other one out at incredible speed. HVS3 is heading out into the void, and it will never return. Now imagine the same scenario, but instead of a binary star system, it's a binary black hole system. Two stellar mass black holes orbiting each other, wandering too close to a supermassive black hole. The supermassive black hole captures one and flings the other out at hypervelocity. That flung black hole is now moving at hundreds or thousands of kilometers per second, fast enough to cross the galaxy in tens of millions of years. Fast enough to be anywhere by now, and we'd have no way to detect it unless it happened to pass close to something we're watching. These hypervelocity black holes, if they exist, are the ultimate rogue predators. Faster than normal rogues, harder to predict, capable of crossing vast distances in cosmologically short times. They could have been ejected from the galactic centre billions of years ago, and be on their way back, having looped around the galaxy, approaching from a direction we're not monitoring. We have no catalogue of hypervelocity black holes. We can barely detect hypervelocity stars. The black holes are invisible until they interact with matter, and by then it's too late to track where they came from or where they're going. We're being hunted by invisible predators moving at interstellar speeds, and we have no early warning system, no defense, no plan, just hope. Just the statistical comfort that space is vast, and we are small, and the odds of being hit are low, but low isn't zero. And we've been rolling the dice for 4.5 billion years. How much longer can our luck hold? Let's talk about what we'd actually experience if a rogue black hole entered our solar system. Not the gravitational mathematics, not the orbital mechanics, but the human experience. What would we see? What would we feel? How would we know? The first sign would be astronomical. Observatories around the world would notice something strange. The orbits of outer planets becoming perturbed. Neptune drifting slightly from its predicted position. Uranus showing unexplained acceleration. These changes would be subtle at first, within the margin of error, but they'd grow over months or years as the black hole approached. Amateur astronomers might notice something too. Stars in a particular region of the sky would appear to shift position slightly, to brighten and dim in ways that don't match any known variable star behaviour. Gravitational lensing would create temporary distortions, arcs of light bending around an invisible mass. Scientists would begin to suspect. They'd run models, calculate masses, plot trajectories, and eventually they'd announce it. There's a massive object moving through the solar system. Based on its gravitational effects, it's likely a black hole. And based on its trajectory, it's going to pass within the orbit of Mars. The announcement would be calm, measured, scientific. We'd have months or years of warning, enough time to study the object, to refine predictions, to understand what's coming, and then the panic would begin. Not everyone would panic. Some people would deny it, would claim the scientists are wrong, would insist that black holes don't exist or can't reach us or are just theoretical constructs. Others would accept it with strange calm, would treat it as fascinating, as an opportunity to witness something unprecedented. But most people would be terrified, because a black hole is primal fear. It's the void, made manifest. It's the thing that consumes everything, that nothing can escape, that represents absolute ending. And it's coming toward us. Governments would try to maintain order. They'd issue statements about how the black hole's trajectory is being monitored, how it's not expected to come dangerously close to Earth, how there's no immediate threat to human life. They'd be telling the truth, mostly. A black hole passing through the inner solar system wouldn't necessarily destroy Earth directly, but truth doesn't calm fear. People would see footage of black holes in documentaries, those dramatic visualizations of accretion disks and jets of radiation. They'd hear about spaghettification, about tidal forces that would tear a human body apart atom by atom if you fell toward the event horizon. They'd imagine the black hole as a cosmic vacuum cleaner, sucking up everything in its path. The reality would be different, more subtle, but in some ways more terrifying. The black hole wouldn't suck things up. It would simply pass through, its gravity reaching out to tug on planets and asteroids, changing their orbits imperceptibly at first, then more dramatically as it came closer. Markets would crash. Why invest in the future when a black hole is passing through the solar system? Why save money? Why build infrastructure? Why plan for retirement when the fundamental stability of Earth's orbit might be about to change? Some people would flee to bunkers, as if concrete and steel could protect them from gravitational forces. Others would gather in cities, wanting to be with people, wanting to face the unknown together rather than alone. Religious movements would explode, some seeing the black hole as divine judgment, others as a test of faith, still others as proof that the universe is fundamentally hostile to life. Scientists would be working frantically, running simulations, trying to predict exactly what would happen as the black hole passed. Where would Earth's orbit shift to? How much would the climate change? Would the moon be torn away? Would the asteroid belt become destabilized? The answers would be uncertain. Too many variables, too much dependence on the exact mass and trajectory of the black hole, too much chaos in the gravitational interactions between multiple bodies. The best they could offer would be probability ranges, a 30% chance of significant orbital change, a 10% chance of losing the moon, a 5% chance of catastrophic asteroid bombardment. Those numbers wouldn't comfort anyone. As the black hole approached as it passed through the outer solar system, we'd begin to see the effects. Neptune's orbit would change measurably. Some of its moons might be stripped away, sent tumbling into independent orbits around the Sun, or flung out of the solar system entirely. Uranus would wobble. Saturn's rings, those delicate structures held in place by gravitational resonances, would begin to destabilize. We'd watch this happen in real time, or as close to real time as the light speed delay allows. Telescopes would track every change, every perturbation, and the data would be analysed, incorporated into models, used to refine predictions about what would happen when the black hole reached the inner solar system. And then it would arrive. The black hole would cross the orbit of Mars, pass through the asteroid belt, come within astronomical units of Earth. We'd feel it. Not directly. The tidal forces at that distance wouldn't be strong enough to affect human bodies, or even Earth's crust significantly. But we'd feel it in the way sailors feel a storm coming, in the atmospheric pressure changes that precede a hurricane. Except this would be a gravitational storm, a warping of space-time itself, and while our bodies wouldn't register it consciously, our instruments would scream warnings. Satellites would begin to fail, not because the black hole damaged them directly, but because their orbits would be changing. And orbital changes at satellite altitudes happen fast. A satellite designed to remain in geosynchronous orbit would find itself drifting, its position-keeping fuel exhausted, trying to compensate for gravitational perturbations it was never designed to handle. GPS would fail, communication networks would degrade, weather satellites would lose their positions, and we'd be plunged into a kind of technological darkness, forced to rely on ground-based systems, on physical infrastructure, on methods of communication we thought we'd outgrown. The moon would move, not dramatically, not enough to be visible to the naked eye in a single night. But over weeks, as the black hole passed, the moon's orbit would shift. It might move closer to Earth or farther away. It might develop a more eccentric orbit, swinging closer and farther in its monthly cycle. The tides would change. Coastal cities would flood or find their harbours exposed as sea level shifted unpredictably, and Earth itself would shift. Our orbit around the Sun would change, maybe becoming slightly more elliptical, maybe shifting our average distance from the Sun by a few million kilometres. That doesn't sound like much, but it's enough to change the amount of solar radiation we receive, enough to trigger climate shifts that would take decades to fully manifest. We'd survive the passage, The black hole would move through and beyond, continuing its journey through the galaxy, leaving us behind. But we'd be changed. Our solar system would be different, subtly rearranged by the gravitational influence of an object we couldn't see, couldn't touch, couldn't affect in any way. And we'd spend the rest of human history looking at the sky differently, knowing that invisible predators move through the darkness, knowing that we were hunted once and survived only because we weren't quite on the predator's direct path. Let's talk about close encounters now. Really close encounters. The kind that astronomical statistics say shouldn't happen, but that, given infinite time, eventually will. Imagine a rogue black hole on a trajectory that brings it within the Roche limit of Earth. The Roche limit is the distance at which tidal forces from a massive object become strong enough to tear apart a smaller object held together by its own gravity. For Earth, with our internal structure and composition, the Roche limit from a stellar mass black hole would be a few thousand kilometers. Closer than the Moon, closer than most satellites. Close enough that if the black hole passed at this distance, Earth would begin to come apart. Not explosively, not like a planet being hit by a giant impact, but gradually, inevitably, as the side of Earth facing the black hole experiences stronger gravity than the side facing away. The difference in gravitational force would create tidal stresses stronger than the chemical bonds holding rock together, stronger than Earth's own gravity trying to keep the planet spherical. The crust would crack. Deep cracks running around the planet like the segments of an orange. Magma would surge up through the cracks as internal pressure found release. Volcanoes would erupt globally, not just at plate boundaries, but anywhere the crust had been weakened by tidal stress. The atmosphere would begin to strip away. The side of Earth facing the black hole would experience stronger pull than the side facing away, and the atmosphere, held to the planet only by gravity, would start to stream toward the black hole. Not quickly at first, but over hours or days as the black hole approached and then receded. Billions of tons of air would be pulled away into space. The oceans would follow. Water would rise on the side facing the black hole. Tides hundreds or thousands of meters high. Not the gentle rise and fall we're used to, but violent, catastrophic surges that would sweep across continents. And as with the atmosphere, some of that water would be stripped away entirely, pulled into space where it would freeze and eventually fall into the black hole or scatter into the void. Earth wouldn't be completely destroyed by a close pass. We're not talking about the planet disintegrating into rubble. But it would be rendered uninhabitable. The atmosphere would be too thin to breathe. The surface would be scoured by tidal floods and volcanic eruptions. The crust would be fractured, unstable, continuing to experience earthquakes and eruptions for thousands or millions of years as it tried to settle into a new equilibrium. Any humans who survived would be those in sealed shelters, underground bunkers with their own air supplies and food stores, and they'd emerge into a world that could no longer support them. A dead planet orbiting a sun that suddenly seemed very far away. The probability of this happening is extraordinarily low. For a rogue black hole to pass within a few thousand kilometers of Earth would require a coincidence of trajectory and timing so improbable that it borders on impossible. But impossible isn't the same as never, and the universe has a long time to roll the dice. Let's go even darker. Let's talk about direct impact, about what would happen if a rogue black hole didn't just pass near Earth but pass through it. A stellar mass black hole is small. The event horizon of a 10 solar mass black hole is only about 60 kilometers across. The black hole itself, the singularity at the center, is infinitesimally small, a point of infinite density that occupies no volume in the classical sense. If such a black hole were to impact Earth, moving at hundreds of kilometers per second, it would punch through the planet like a bullet through fog. The entry point would be catastrophic. The black hole's gravity would compress matter in front of it to densities we can barely imagine, creating a shock wave that would propagate through the planet. Rock would vaporize. The crust would be blown outward in a cone of debris. A column of Earth's interior would be dragged along with the black hole. pulled by tidal forces into a stream of matter falling toward the event horizon. The black hole would pass through Earth in seconds. Moving at, say, 400 kilometers per second, it would traverse the planet's 12,000 kilometer diameter in 30 seconds. 30 seconds of the most intense gravitational stress Earth has ever experienced. As a point of extreme space-time curvature rips through its interior, the exit wound would be similar to the entry wound. An explosive release of material, a cone of debris hurled into space, and in the black hole's wake, a tunnel through the planet, a cylindrical void where matter used to be, now collapsing inward as the surrounding rock tries to fill the space. Earth wouldn't hold together. The structural damage would be too severe. The planet would begin to break apart, not into a debris field. Gravity would still hold most of the mass together, but into a distorted, unstable shape. Massive earthquakes would circle the globe. The surface would heave and crack. Volcanic eruptions would darken the sky with ash. And the black hole? It would continue on, barely affected by its passage through our planet. It would have gained a tiny amount of mass from the matter it consumed, but compared to its original 10 solar masses, Earth's contribution would be negligible. It would continue its journey through the solar system and beyond, another invisible predator moving through the galaxy, and in its wake it would leave a dying world. No one would survive this. No shelter would protect you from the planet breaking apart beneath your feet. Humanity would end in 30 seconds, in the time it takes a black hole to pass from one side of Earth to the other. The probability of this is so low that it's not worth calculating. Direct impact is functionally impossible given the size of black holes compared to the vastness of space, but we're exploring the full range of the nightmare. We're mapping every scenario, from the distant and probable to the close and nearly impossible, because understanding the full scope of the threat is how we come to terms with it, how we move from fear to acceptance. Let's shift perspective now. Let's talk about detection not as a problem to solve, but as a source of existential dread. Imagine we develop the perfect detection system, a network of gravitational wave detectors and optical telescopes and micro-lensing surveys that, working together, can identify and track every rogue black hole in the galaxy. We map them all. We know where they are, where they're going, when they'll arrive, and we discover that there are far more than we thought. Not millions, but billions. The galaxy is thick with them, wandering stellar mass black holes and intermediate mass black holes, and perhaps even primordial black holes from the early universe, objects we never predicted, scattered through space like landmines. We can see them now, we can track their trajectories, and we realize that collisions, while still rare, are inevitable over cosmic timescales. We identify several black holes that will pass dangerously close to our solar system in the next million years. We find dozens that will pass close enough to perturb the Oort Cloud to send comets cascading inward, and we realize there's nothing we can do about it. We can't deflect a black hole, we can't change its trajectory, we can't shield ourselves from its gravity. All we can do is watch and wait and hope that close doesn't become too close. Perfect detection doesn't give us power, it gives us perfect knowledge of our powerlessness. Would we want that? Would we prefer to know that a black hole will pass through the inner solar system in 50,000 years, giving us millennia to observe its approach and refine our predictions, but also millennia to dread the encounter? Or would we prefer ignorance, living our lives without the weight of future catastrophe, pressing down on every decision? There's no good answer. Knowledge is power, except when it isn't, except when it's just knowledge of inevitabilities you cannot change. Some people would want to know, would dedicate their lives to tracking these objects, to understanding their trajectories, to predicting their effects on the solar system. They'd find meaning in the study, in the accumulation of data, in the advancement of understanding, even when understanding doesn't lead to control. Others would choose ignorance, would avoid the data, would refuse to think about the distant threats, would focus on the immediate, the tangible, the problems they can actually solve. And neither approach would be wrong. Both would be valid ways of coping with the knowledge that invisible predators hunt through the darkness and we are fundamentally prey. Let's talk about timescales now, because that's where the horror becomes manageable, where the immediate threat becomes cosmic background, radiation. The Milky Way is 100,000 light-years across. A rogue black hole moving at 400 kilometers per second would take 750 million years to cross from one side to the other. That's an immense amount of time. Longer than complex life has existed on Earth. Longer than the dinosaurs roamed and died and were buried and fossilized and discovered. On these timescales, the positions of rogue black holes are almost static. They're moving, yes, but so slowly relative to galactic distances that we can think of them as fixed points, as obstacles in space that the solar system might or might not encounter as we orbit the galactic centre. Our solar system completes one orbit around the Milky Way every 225 million years. In the 4.5 billion years Earth has existed, we've made about 20 orbits. In each orbit, we've passed through different regions of the galaxy, encountered different stellar neighbourhoods, different densities of gas and dust and stars, and presumably different densities of rogue black holes. We've survived 20 galactic orbits without catastrophic encounter. That suggests either that rogue black holes are rare enough that we can go hundreds of millions of years between close passes, or that we've been lucky, or that previous encounters left no geological record we can identify. Over the next 225 million years, as we complete our current orbit and begin the next, we'll encounter whatever objects lie along our path. Maybe nothing dangerous. Maybe a distant rogue that perturbs the Oort Cloud but causes no immediate harm. Maybe something closer. We can't predict it. The galaxy is too complex, our maps too incomplete, the trajectories too chaotic over these timescales. All we can say is, it hasn't happened yet. We've made it this far, and that's comforting in a way. We're not special, not protected, not exempt from the laws of physics. But we're also not doomed. The universe isn't actively trying to kill us. It's just indifferent, and in that indifference, there's space for survival. For a while, for as long as luck and statistics allow. Let's think about primordial black holes now, because they might be the most unsettling variant of the rogue black hole threat. Primordial black holes are hypothetical objects that could have formed in the first moments after the Big Bang, when the universe was incredibly dense, and even small fluctuations in density could collapse into black holes. Unlike stellar mass black holes, which require a massive star to collapse, primordial black holes could have any mass, from microscopic, less massive than an asteroid, to stellar mass and beyond. If primordial black holes exist, and we have no confirmed detections yet, but also no proof they don't exist, they could be scattered throughout the galaxy. Not orbiting stars, not born from supernovae, but wandering since the beginning of time, remnants of the universe's first moments. A primordial black hole passing through the solar system would be even harder to detect than a stellar mass rogue. If it's small, if it's only the mass of a large asteroid, it might not create significant gravitational lensing effects. It might not perturb planetary orbits enough for us to notice. It could pass right through the inner solar system and we'd never know, unless it hit something, unless it passed close enough to Earth to interact with our planet's matter. A small primordial black hole wouldn't tear Earth apart, its gravity wouldn't be strong enough, but it could punch through the planet just like a larger black hole, except faster, with less damage but still catastrophic for anything in its path. Imagine a primordial black hole the mass of Mount Everest, compressed to a size smaller than an atom, moving through space at 600 kilometers per second. It enters Earth's atmosphere over the Pacific Ocean. It's so small that air molecules can't interact with it in any normal sense. It doesn't create a sonic boom. It doesn't heat up from friction. It just falls, pulled by Earth's gravity, accelerating as it approaches the surface. It hits the ocean. Water can't slow it. It passes through the ocean, through the crust, into the mantle, as if they weren't there. Rock and metal and water are mostly empty space, and the black hole is smaller than an atom, It threads through the spaces between atoms like a needle through cloth, but its gravity, compressed into such a small volume, is intense. As it passes, it pulls on nearby matter, creating a wake of disturbed atoms, generating heat, producing radiation. The passage leaves a tunnel, microscopic but real, through which matter flows, pulled by the black hole's gravity. The black hole exits on the other side of the planet, emerges into space above the Indian Ocean, and continues on, its trajectory barely altered by passing through Earth. Behind it, in the planet's interior, chaos. The tunnel is collapsing, but the heat generated by the black hole's passage has created a column of superheated material. If the black hole passed through the crust, that column might erupt, a volcanic explosion appearing in a region with no tectonic activity, no prior warning. If it passed through the core, it might have disrupted the convection patterns that generate Earth's magnetic field. Over years or decades, we'd notice the magnetic field weakening, shifting, possibly collapsing entirely, leaving Earth exposed to solar radiation in ways that would make the surface uninhabitable. We wouldn't know what caused it. We'd have theories. Solar storms, changes in the core's composition, quantum fluctuations in the iron dynamo. But we wouldn't think to blame a primordial black hole that passed through this planet in a fraction of a second and left no trace except the damage in its wake. This might have happened already. Earth has experienced magnetic field reversals, sudden climate changes, extinction events we can't fully explain. Some of them might have conventional explanations, but some might not, and we'd never know, because the black hole would be long gone, invisible, undetectable, just another rogue predator that hunted us and moved on. How many primordial black holes might there be? We don't know. Some models suggest they could make up a significant fraction of dark matter, the mysterious substance that outweighs visible matter in the universe by a factor of 5. If that's true, if primordial black holes are everywhere, scattered through space like dust, then we're not just being hunted by stellar mass rogues. We're swimming through a sea of invisible predators, and we survive only because most of them are too small to affect us, and because space is vast enough that close encounters remain rare. But rare isn't never, and if primordial black holes are common, one of them will eventually pass close enough to matter. Let's talk about defense, because that's the natural human response to any threat. Can we protect ourselves? The answer is no, not really. Not against black holes. We can't deflect them. They're too massive, moving too fast, governed by trajectories set by the gravity of the entire galaxy. Even if we had rockets powerful enough to push against a black hole's mass, which we don't and might never have, we couldn't change its path significantly enough to matter. We can't shield ourselves from their gravity. Gravity isn't like radiation that you can block with lead, or electromagnetic fields you can deflect with charged barriers. Gravity is the curvature of space-time itself, and you can't shield yourself from that any more than you can step outside of time. We can't destroy them. Black holes are the most stable objects in the universe. They don't decay, don't dissolve, don't respond to any known physical process except Hawking radiation, which operates on timescales trillions of times longer than the current age of the universe. All we can do is adapt to the consequences. If a rogue black hole perturbs the Oort Cloud and we face increased comet bombardment, we can try to deflect individual comets. We have proposals for that. Kinetic impactors, gravity tractors, even nuclear explosions to vaporize or redirect incoming objects. But each deflection would require years of preparation, massive resources, perfect execution. And if we're facing dozens or hundreds of comets over a million-year period, we couldn't stop them all. We'd have to choose which cities to protect, which populations to evacuate, which impacts to accept as inevitable. If a rogue black hole changes Earth's orbit, if our climate shifts, we can try to adapt. Migrate toward the equator if the planet cools, or toward the poles if it warms. Develop new agriculture for new climate zones. Build infrastructure to handle rising or falling sea levels. But adaptation takes time, and populations resist migration, and political systems struggle to coordinate on timescales longer than election cycles. We'd face wars over resources, refugee crises, the collapse of nations unable to feed their populations in the new climate. We'd survive? Probably. Humans are adaptable. We've survived ice ages and volcanic winters and asteroid impacts in the past. But survival wouldn't mean prosperity. It would mean endurance, hardship, the winnowing of populations down to those who could adapt fast enough and ruthless enough to secure what they needed. Is there any defense? Any action we could take that would actually protect us from rogue black holes? Yes. 1. We could leave, not Earth, not the solar system, but this region of the galaxy. We could become an interstellar species, spread across multiple star systems, diversify our presence so that no single event, no single rogue black hole, could threaten all of humanity. It's not a defense in the traditional sense. It's not stopping the threat. It's distributing ourselves so widely that the threat becomes survivable at the species level, even if individual worlds are destroyed. This would require technology we don't currently have. Faster than light travel, or at least near light speed generation ships. The ability to terraform other worlds, or to build habitats in deep space. The political and social will to fund projects that wouldn't pay off for centuries. It's possible. Not easy, but possible. And it might be necessary not just because of rogue black holes, but because of all the cosmic threats we face. Supernovae, gamma-ray bursts, asteroid impacts, eventually the death of our own sun. The universe is dangerous. Staying in one place, putting all our eggs in one planetary basket, is a long-term extinction risk. But spreading out, becoming interstellar, surviving as a distributed network of worlds and habitats, that's a defense. Not perfect, but real. And maybe that's the ultimate lesson of rogue black holes. Not that we should fear them, but that we should recognize our fragility, our dependence on a single world, orbiting a single star in a galaxy full of invisible threats. We're prey, but prey can evolve, prey can adapt, prey can become hard to catch, and maybe, given enough time, we can become something more than prey. Let's shift our focus now. Let's move from the mechanics of destruction to the philosophy of living under constant invisible threat. Because that's what rogue black holes represent ultimately. The universe's indifference made manifest in objects we cannot see, cannot predict, cannot escape. We live our lives assuming stability. We assume Earth's orbit will remain constant, that the sun will rise tomorrow at the expected time, that the seasons will follow their familiar patterns. We build our civilizations on this assumption of cosmic stability, planning decades and centuries ahead, constructing buildings meant to last generations, planting trees we'll never see fully grown. But that stability is contingent. It depends on nothing massive passing close enough to disturb our orbital mechanics. It depends on the gravitational influences on our solar system remaining within the range they've occupied for billions of years. It depends on luck, on probability, on the vast emptiness of space keeping dangerous objects at safe distances. Rogue black holes remind us that this stability isn't guaranteed. It's temporary. It's a gift from statistics, from the improbability of collision in a universe where space vastly outweighs matter. We've been safe so far not because we're protected, but because we've been lucky, and luck is not a sustainable defense strategy. How do you live with this knowledge? How do you plan for the future, raise children, build societies, when the foundation could be kicked out from under you by an invisible object you never saw coming? Some people would find this paralyzing. The awareness that everything could change, that Earth's orbit could be altered, that our entire world is vulnerable to threats we can neither detect nor defend against. It would make planning feel futile, would drain the meaning from long-term projects. Why build a cathedral that takes generations to complete when a rogue black hole could perturb our orbit and render the planet uninhabitable before the final stone is laid? Why fight climate change? Why preserve biodiversity? Why work toward a sustainable future when cosmic catastrophe could erase all our efforts in a geological instant. This is the nihilism of cosmic horror, the sense that our actions don't matter because we're ultimately at the mercy of forces so far beyond our control that we're essentially insects hoping not to be stepped on by giants we can't see. But there's another way to think about it, another response to the awareness of cosmic vulnerability. Everything is temporary, everything ends. The question is not whether but when, and what you do in the meantime. Earth's orbit will change eventually. Maybe from a rogue black hole, maybe from the sun's evolution as it ages, maybe from interactions with other stars as the Milky Way and Andromeda collide billions of years from now. The stability we experience is temporary, a brief plateau in a universe of constant change. Knowing this doesn't make your actions meaningless, it makes them immediate. It strips away the false comfort of permanence and forces you to find meaning in the present, in the doing rather than in the eternal preservation of what's done. Build a cathedral not because it will last forever, but because building it matters now, because the act of creation, the beauty of the structure, the community that forms around its construction, those things have value in themselves, regardless of how long the building stands. Fight climate change not to save the planet for eternity, but to make the present and near future better, to reduce suffering, to preserve the conditions that allow life to flourish for as long as those conditions can be maintained. The rogue black holes hunting through the galaxy don't diminish the value of what we do. They clarify it. They force us to confront the fact that value exists in the moment, in the experience, in the quality of life and awareness and connection, not in some imagined permanence that was never possible anyway. This is a hard teaching. We're conditioned to think in terms of legacy, of lasting impact, of echoes into the future. But the universe is teaching us something different. Be here now. Love what is temporary. Create knowing that creation itself is the point, not the eternal preservation of what's created. Rogue black holes are one of many reminders of this truth. Asteroid impacts, supernovae, gamma-ray bursts, the heat death of the universe. All of them say the same thing: nothing lasts. And in the face of that truth we have a choice: despair or presence, nihilism or engagement with the temporary beauty of existence. Let's talk about consciousness now, about what it means to be aware in a universe full of invisible threats. You're a pattern of information instantiated in neurons. Your consciousness, your sense of self, your experience of being you, it all depends on the continued functioning of your brain, which depends on the continued functioning of your body, which depends on Earth remaining in an orbit that supports liquid water and breathable atmosphere. The chain of dependencies is long and fragile, and at the end of it, at the foundation of everything that allows you to exist, is cosmic luck. The luck that no rogue black hole has passed close enough to disrupt the solar system in the time it took for life to evolve, and for you, specifically, to be born. You exist because of an unbroken chain of improbable events stretching back billions of years. Every generation of your ancestors survived long enough to reproduce. Every cosmic threat that could have sterilized Earth either missed or occurred at a time when life was resilient enough to recover. Every rogue black hole that passed through the galaxy happened to pass far enough from our solar system that it didn't matter. The odds of you existing are infinitesimally small, and yet you do exist. You're here, aware, thinking about rogue black holes and cosmic probabilities. What does that mean? One interpretation: you're incredibly lucky. You won the cosmic lottery. You exist in a timeline where all the improbable things that had to happen for you to exist actually happened. Another interpretation: your existence is inevitable from your perspective. You can only exist in timelines where the conditions for your existence are met. From your subjective viewpoint, the probability of your existence is 100%, because you're only aware in the timelines where you exist. Both are true in a way. You're lucky and inevitable, improbable and certain, depending on the frame of reference, and the rogue black holes don't change this. They're part of the cosmic background, part of the set of threats that could end your existence but haven't yet. They've been wandering the galaxy for billions of years, and they'll continue wandering long after you're gone. Your awareness of them doesn't increase the danger, it just makes the danger conscious, brings it into the light of your attention. And maybe that's valuable. Maybe being aware of cosmic threats, even ones you can't defend against, is part of what it means to be a conscious being in a dangerous universe. You're not just a pattern of neurons firing, you're the universe becoming aware of itself, of its dangers and beauties, its stability and chaos. Through you, the cosmos knows about rogue black holes. Through your fear and wonder and contemplation, the universe experiences its own threatening nature. That's not nothing, that's extraordinary. Let's talk about timescales again, but from a different angle. Let's think about how long consciousness has existed, and how long it might continue to exist. Complex life on Earth has existed for about 600 million years. Conscious life, life that can think about its own existence and the nature of the universe, has existed for maybe a few million years if we're generous about what counts as consciousness. That's a tiny fraction of Earth's history, and an infinitesimal fraction of the universe's history. Consciousness is recent, fragile, rare, and it exists in a universe that doesn't care about it, that generates threats, rogue black holes, supernova, gamma-ray bursts, without regard for whether consciousness survives. How long might consciousness persist? On Earth, we have maybe 1 billion years before the sun's increasing luminosity makes the planet uninhabitable. That's assuming no cosmic catastrophe ends it sooner. Assuming no rogue black hole, no asteroid impact, no gamma-ray burst. 1 billion years is a long time by human standards, long enough for evolution to produce unimaginable new forms of life and intelligence, long enough for consciousness to explore possibilities we can't conceive of. But it's finite. Earth's consciousness has an expiration date set by stellar evolution, if not by cosmic catastrophe. Unless we leave. Unless consciousness spreads to other worlds, other star systems, becomes distributed across the galaxy, or even across multiple galaxies, then the timeline extends. Instead of 1 billion years, we have trillions. The lifetime of the longest-lived stars, red dwarfs that could burn for 10 trillion years or more. Consciousness could persist for an appreciable fraction of the universe's lifetime, could witness the death of the last stars, the evaporation of the last black holes, the approach of heat death itself. And in that time, in those trillions of years, how many rogue black holes would consciousness encounter? How many close calls? How many colonies lost to gravitational perturbations? How many worlds rendered uninhabitable by passing black holes? Hundreds? Thousands? Millions? It doesn't matter. If consciousness is distributed widely enough, if we're resilient enough, we could survive all of them. Each encounter would be a tragedy for the world affected, but not an extinction event for consciousness as a whole. This is the long-term strategy. Not preventing rogue black holes from being dangerous, we can't, but making consciousness robust enough to survive the dangers, spread out, diversify, build redundancy into our existence so that no single catastrophe can end us. It's not a solution that helps the people on the world that gets hit. They're still destroyed, still suffer the consequences, but it's a solution at the species level, at the consciousness in the universe level, and maybe that's the best we can do. Accept that individuals and worlds are temporary, vulnerable, subject to forces beyond their control. But work to make consciousness itself, the phenomenon of the universe being aware, as persistent as physics allows. Let's talk about meaning one more time, because it's the question that underlies all of this. If rogue black holes can destroy worlds, if consciousness is fragile and temporary, if everything we build will eventually be lost to cosmic forces we can't control, why does anything matter? This is the ancient question, made more acute by cosmic awareness. It's one thing to know you'll die, that your individual life is temporary. It's another to know that your entire species, your entire world, Your entire lineage of consciousness might be ended by an object you can't see, can't predict, can't defend against. If nothing lasts, if everything ends, where does meaning come from? The traditional answer is legacy. We matter because we leave something behind, because our actions echo into the future through their effects on the world and on other people. But rogue black holes threaten that answer. If the world itself can be destroyed, if the far future is not guaranteed, then legacy becomes uncertain. What you leave behind might not last long enough to matter. So we need a different answer, one that doesn't depend on permanence, on echoes into the far future, on the survival of what we create. Meaning comes from experience, from the quality of awareness in the present moment, from the relationships between conscious beings, the beauty we perceive, the understanding we achieve, the love we give and receive. None of that requires permanence. A sunset is meaningful even though it lasts only minutes. A piece of music is beautiful even though it ends. Love between people is real even though both will die. Meaning exists in the experiencing, not in the eternal preservation of what's experienced. Rogue black holes can destroy worlds, but they can't erase the fact that those worlds existed, that consciousness arose on them, that beings lived and loved and wondered. The experiences happened, the awareness was real. And that reality doesn't depend on continuation. It depends only on having occurred. You matter because you're aware, because you're experiencing, because you're part of the universe knowing itself. And that mattering is complete in each moment. It doesn't require validation from a future that may or may not come. This is the deepest response to cosmic horror, accepting that meaning is immediate, local, experiential, not dependent on permanence or cosmic significance. You don't need the universe to care about you for your life to have meaning. You care, and that's enough. Let's talk about wonder now, because fear and wonder are two sides of the same coin, two responses to the incomprehensible vastness and strangeness of the universe. Rogue black holes are terrifying, invisible predators hunting through the galaxy, capable of destroying worlds, impossible to defend against. That's the fear response, and it's valid. These objects are genuinely dangerous, genuinely beyond our control. But they're also astonishing. They're stellar corpses wandering through space, objects so massive that they warp space-time itself, so dense that their event horizons are measured in kilometers even though they contain the mass of multiple suns. They're remnants of the most violent events in the universe. Supernovae that tore apart stars and kicked the remnants out at hundreds of kilometers per second. They've been wandering for millions or billions of years, silent and invisible, following trajectories set by the gravity of the entire galaxy. They're perfect natural experiments in extreme physics, laboratories where gravity is so strong that our usual intuitions break down, where space-time curvature becomes significant, where quantum mechanics and general relativity both matter, and we don't fully understand how they interact. They're beautiful in an austere, mathematical way. Not beautiful like a sunset or a piece of music, but beautiful like an equation that perfectly describes nature, beautiful in their simplicity and inevitability, and they're part of the universe that created us, part of the same cosmic story that led to Earth and life and consciousness. The elements in your body were forged in stars. Some of those stars exploded and formed black holes. The black holes wander the galaxy. You think about them, fear them, wonder at them. You're part of the same system, made of the same stuff, governed by the same laws, part of the same grand unfolding of matter and energy and space-time. That's not comforting in the sense of making you safe, but it's connecting. It places you in context, makes you part of something larger than yourself, part of the universe's ongoing exploration of what's possible. Fear and wonder can coexist. You can be terrified of rogue black holes and also amazed by them. You can recognize the danger and also appreciate the elegance, the physics, the sheer cosmic audacity of these objects, and in that coexistence, in that ability to hold both fear and wonder simultaneously, you find a more complete relationship with the universe, not denying the danger, not pretending you're safe, but also not reducing the cosmos to a threat, not seeing it only as a source of fear. The universe is dangerous and beautiful, threatening and amazing, full of invisible predators and also full of stars and galaxies and the possibility of life and consciousness. Both are true, and you can hold both truths, can live in the tension between them, can be appropriately cautious and also appropriately awestruck. Let's think about other civilizations now if they exist. Other conscious beings on other worlds, also vulnerable to rogue black holes, also living in a universe of invisible threats. If intelligent life is common in the galaxy, then rogue black holes have affected many civilizations. Some might have been destroyed by close encounters, their worlds rendered uninhabitable before they could develop the technology to leave. Others might have detected rogue black holes approaching, might have had centuries or millennia of warning, might have made the choice to evacuate their world or to stay and hope the black hole passed far enough away. How would different civilizations respond? Would they all react with fear, or might some see it differently? Might some have philosophies or psychologies that interpret cosmic threats in ways we can't imagine? Maybe there are civilizations that worship black holes, that see them as divine or sacred, that interpret a passing rogue not as a threat but as a visitation. Maybe there are beings for whom the concept of threat doesn't exist, who experience reality so differently that the idea of being harmed by a black hole doesn't compute. Or maybe they all fear black holes the way we do. Maybe fear of massive, invisible, unstoppable objects is a universal response, something any conscious being would develop. If we ever make contact with other civilizations, if we exchange information about our experiences and fears and wonders, rogue black holes will be part of the conversation. Have you encountered them, we might ask? Have you lost worlds to them? How do you defend yourselves? How do you live with the knowledge that they're out there, invisible, unpredictable? And maybe they'll have answers we haven't thought of. Maybe they'll have detection methods we haven't developed, philosophical frameworks that make the threat easier to bear, technologies that allow them to survive encounters we think are unsurvivable. Or maybe they'll say, yes, we know them, we fear them too. We've lost worlds, we've adapted, we've survived, and we'll continue surviving together for as long as the universe allows. There's comfort in that idea, that we're not alone in facing cosmic threats, that other beings share our vulnerability and our resilience, that we might learn from each other how to live in a dangerous universe. But we don't know if other civilizations exist. We might be alone, the only consciousness in the galaxy, perhaps in the observable universe. If that's true, then the responsibility is ours alone, to survive, to persist, to keep consciousness alive in a universe that doesn't care whether consciousness exists. And the rogue black holes become not just a threat, but a test. Can consciousness survive in a universe of invisible predators? Can we become robust enough, distributed enough, resilient enough to persist despite the dangers? We don't know yet. We're still here, still vulnerable, still confined mostly to one planet orbiting one star. But we're trying, we're learning. We're beginning to think about how to become an interstellar species, how to spread out, how to survive. And maybe that's enough for now. Not success, but effort. Not safety, but awareness of the danger and willingness to work toward survival. Let's talk about acceptance now. Real acceptance. Not as defeat, but as clear-eyed recognition of reality. Rogue black holes exist. They're wandering the galaxy. We can't stop them. We can't see most of them. One might pass close to our solar system tomorrow, or in a million years, or never. We don't control this. We can't make it safe. We can only adapt to the reality of living in a universe where such objects exist and occasionally interact with the matter they pass through. That's not comforting in the traditional sense. But there's a kind of peace in accepting what you can't change, in letting go of the need for absolute safety, in recognizing that danger is part of existence and always has been. Our ancestors faced invisible threats too. Diseases they couldn't see, weather patterns they couldn't predict, predators that hunted at night when vision failed. They survived not by eliminating all threats, but by being resilient, adaptable, capable of responding to danger when it appeared. We're facing threats on a larger scale, cosmic rather than terrestrial, but the principle is the same. We can't eliminate danger. We can only become good at surviving it, and we have advantages our ancestors didn't. We have science, technology, global cooperation, the ability to understand the threats we face even when we can't eliminate them. We know about rogue black holes, we're developing detection methods, we're thinking about how to become an interstellar species, how to distribute ourselves widely enough that no single catastrophe can end us. We're not helpless, we're not safe, but we're not helpless. And in that middle ground between terror and complacency, between denial and despair, we find a workable relationship with danger. Yes, rogue black holes are out there. Yes, they're dangerous. Yes, we might encounter one. And yes, we'll deal with it as best we can when, or if it happens. We'll adapt, survive, continue. That's all we can do, and it's enough. It has to be enough, because it's the only option that leads to continuation. Despair leads to stagnation. Denial leads to unpreparedness. Only acceptance combined with active response leads to resilience. So we accept the rogue black holes, we acknowledge the danger, we work to detect them, to understand them, to develop strategies for surviving their effects, and we live, fully, presently, engaged with the world and with each other, not despite the danger but alongside it. The danger is part of reality. Reality is worth engaging with. Therefore, we engage, knowing the risks, accepting them, and choosing to continue anyway. That's not optimism or pessimism, it's realism. And realism, clear-eyed and unflinching, is the foundation of both survival and meaning. Let's drift into quieter contemplation now. Let's let the immediate fear of rogue black holes fade and replace it with something deeper, more meditative, more accepting of our place in a cosmos that contains such objects. You've been thinking about invisible predators for a while now, objects that hunt without intention, that threaten without malice, that exist simply because the laws of physics allow them to exist and the history of the universe has created them. The fear is natural. These objects are genuinely dangerous, genuinely beyond our control. But fear, held too long, becomes exhausting. It paralyzes rather than motivates. It diminishes life rather than protecting it. So let's transform the fear, not deny it, not pretend the danger doesn't exist, but alchemize it into something we can live with, something that enriches rather than diminishes our experience of being alive. Start by recognizing scale. The galaxy is 100,000 light years across. It contains 200 to 400 billion stars. The spaces between stars are vast beyond human comprehension. Even with millions of rogue black holes wandering through this space, the probability of any particular star system encountering one in any particular million-year period is extraordinarily small. We've been safe for 4.5 billion years. That's not luck alone. That's the natural consequence of space being mostly empty, of gravity operating, over distances that dwarf the size of even the most massive objects. The rogue black holes are out there, yes, but out there is so vast, so incomprehensibly large, that their presence doesn't immediately threaten us any more than the presence of sharks in the ocean immediately threatens someone living in a landlocked city. The threat is real but distant, possible but improbable, worth being aware of but not worth constant fear. Now recognize your own temporariness. You will die, not from a rogue black hole, almost certainly, but from something. Age, disease, accident. The simple fact that biological organisms don't last forever. Your individual existence is limited to decades, maybe a century if you're lucky and medical science continues advancing. In that time frame, the rogue black holes haven't moved appreciably from their current positions. They're effectively static on human timescales. The threat they pose is not to you, but to your distant descendants, to civilizations that might exist millions of years from now, to a future so far removed from your experience that it's essentially abstract. Does that make the threat less real? No, but it makes it less immediate. It moves it from the category of things you need to worry about personally to the category of things humanity as a whole needs to be aware of and plan for collectively. You can care about that collective planning without carrying the weight of it personally. You can support research into detection methods, advocate for space exploration and the development of interstellar capabilities without feeling personally responsible for solving the problem. The responsibility is distributed across billions of people and potentially trillions of future people. Your part is small, manageable, not the weight of the world, but a fraction of it, shared with everyone else. Now recognize beauty, not despite the danger, but interwoven with it. The same physics that makes rogue black holes dangerous makes them beautiful. Einstein's equations, the geometry of curved space-time, the interplay of mass and energy and the fabric of reality itself. It's elegant. It's profound. It's the universe revealing its deep structure to those capable of understanding it. You can study black holes, can learn the mathematics that describes them, can trace the curvature of space-time around an event horizon and feel wonder. Not comfortable wonder, not the gentle appreciation of a sunset, but sharp, awe-filled wonder at the extremes of physics, at the boundaries of what reality allows. Rogue black holes are nature operating at maximum intensity. They're what happens when gravity wins completely, when matter collapses past the point where any other force can resist. They're the universe showing you what it's capable of, what emerges from its laws when conditions are extreme enough. And you get to know about them. You get to understand, at least partially, what they are and how they work and why they exist. You're conscious in a universe that contains black holes, and your consciousness can comprehend them, can model them mathematically, can predict their behaviour. That's extraordinary. That's a gift, even if the gift includes danger. Let's think about connection now. Not just connection between people, but connection between you and the cosmos itself. The atoms in your body were forged in stars. Some of those stars died in supernovae, the same process that creates stellar mass black holes. You're made of stardust, the cliche goes, but it's literally true. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it was created in stellar furnaces and scattered through space when those stars died. Some of those dying stars created black holes. Others scattered their matter, which eventually condensed into new stars and planets, one of which became Earth, where those atoms assembled into you. You and the rogue black holes are cousins in a way, products of the same processes, manifestations of the same physical laws, part of the same cosmic story. That doesn't make them safe. Family can be dangerous too. But it does place them in context, makes them part of your extended cosmic lineage rather than purely alien threats. You're not separate from the universe that contains rogue black holes. You're part of it. Made of the same stuff, governed by the same rules, part of the same unfolding process. And in that unity, that fundamental non-separation between you and the cosmos, there's a kind of peace. Not safety, but belonging. You belong here, in this universe, with all its beauty and danger and strangeness. The rogue black holes belong here too. They're part of the natural order, consequences of stellar evolution and supernova physics, as much a part of the universe as you are. Neither of you is an accident or an intrusion. Both are expressions of what the universe does, what emerges when matter and energy and space-time interact according to the laws of physics. Let's talk about the present moment now, because that's ultimately where you live, where experience happens, where meaning exists. Right now, as you listen to these words or read them or think about them, Earth's orbit is stable. The sun is shining or will shine tomorrow depending on your time zone and the rotation of the planet. The fundamental constants of physics are doing what they've done for billions of years. No rogue black hole is in the immediate vicinity. No gravitational catastrophe is imminent. You're safe, for now, in the only way that safety ever exists, temporarily, contingently, for this moment. And this moment is enough. It has to be enough, because it's all you ever directly experience. The past is memory, the future is imagination. Only now is immediate, is felt, is real in the visceral sense. A rogue black hole might be approaching, might reach our solar system in 10,000 years or 100,000 or never, but that's future. That's possibility. That's not now. Now, you're here, breathing, thinking, aware, and that awareness, that consciousness, that experience of being, it's not threatened by distant possibilities. It exists fully in the present, complete in itself, valuable for its own sake. The rogue black holes don't diminish this moment. They can't touch the reality of your current experience. They're part of the background, part of the context, part of the larger universe you exist within, but they're not here, not now, not immediate. So you can let them recede, not forget them, not deny their existence, but let them settle into their proper place. Distant objects in a vast galaxy, worth being aware of but not worth constant focus. Be here instead. Be present. Be aware of what's actually happening in your immediate experience rather than what might happen in timescales you won't personally witness. The present is enough. The present is everything. And in the present, right now, you're safe. Enough to continue existing, to continue experiencing, to continue being conscious. Let's think about humanity's long-term trajectory now, the arc of our development from single planet species to potentially something much more distributed and resilient. We're young. So young. Modern humans have existed for maybe 300,000 years. Civilization for perhaps 10,000. Industrial technology for 200 years. Spaceflight for barely 60. On cosmic timescales, we're infants. We've barely begun to explore what's possible, what we might become, where we might spread, and already we're thinking about interstellar travel. Already we're detecting exoplanets, mapping the galaxy, imagining how we might reach other star systems. Already we're taking the first tiny steps toward becoming a multi-world species. It's slow, frustratingly slow from an individual human perspective. But it's happening. And if we survive, if we don't destroy ourselves with nuclear weapons or climate change or biological catastrophe, if we navigate the dangers of our own making, then the cosmic dangers become the next challenge. Rogue black holes are part of that challenge. They're one of many reasons why staying on a single world is a long-term extinction risk. Their motivation for spreading out, for diversifying, for making humanity resilient against cosmic-scale threats. In a way, they're teachers. They're showing us what we need to become, a species distributed across multiple star systems, capable of surviving the loss of individual worlds, resilient enough to persist despite dangers we can't eliminate. We're not there yet. We might not get there. But the rogue black holes, along with asteroids and supernovae and all the other cosmic threats, are pushing us in that direction. They're selecting for resilience. Civilizations that stay on one world eventually face extinction from cosmic catastrophe. Civilizations that spread out, that become truly interstellar, gain a kind of immortality, limited only by the heat death of the universe or other ultimate endings. The rogue black holes are part of the selection pressure. They're part of what shapes which civilizations survive in the long term. And we get to participate in this process. We get to decide collectively whether to rise to the challenge or remain vulnerable. We get to choose whether humanity's story ends on Earth or continues across the stars. That's not a small thing. That's participating in cosmic evolution, in the unfolding of complexity and consciousness across the galaxy and potentially beyond. The rogue black holes are dangerous, but they're also part of the context that might drive us to become something greater than we currently are. Let's drift towards silence now, toward the quiet acceptance that comes when you've thought about a threat from every angle and arrived at peace not through denial but through understanding. Rogue black holes exist. You understand what they are, how they form, what dangers they pose. You've explored the scenarios from distant perturbation to direct impact. You've thought about detection and defense and the limitations of both. You've confronted the fear. You've sat with it, examined it, let it speak. And in the speaking, it's become less overwhelming. Still real, still valid, but not paralyzing. Now you can let it go. Not forever. It might return when you encounter new information, or when something triggers the awareness again. But for now, for this meditation, you can release it. The black holes will do what black holes do. They'll wander the galaxy according to the trajectories set by their formation and by the gravitational influences they've encountered over millions of years. Some will pass close to star systems, some will cause perturbations, catastrophes, changes, and you'll do what conscious beings do. You'll live, experience, create, love, wonder, question. You'll be aware of dangers without being consumed by them. You'll exist in the present while planning for the future. You'll be simultaneously fragile and resilient, vulnerable and enduring. The universe contains rogue black holes. The universe also contains you. Both are remarkable. Both are part of the same cosmic story. Let there be peace between you and the black holes. Not friendship. They're not conscious, can't reciprocate relationship. But peace in the sense of acceptance, of non-resistance, of acknowledging their place in reality without needing to control or eliminate them. They're here. You're here. The galaxy is vast enough for both. Let's talk about legacy one final time, but from a different perspective than before. You won't be remembered by the universe. The cosmos has no memory, no consciousness to recall individuals or even civilizations. When you die, when humanity eventually ends, whether from rogue black holes or other causes, the universe will continue, indifferent, uncaring. That sounds bleak, but there's liberation in it too. You don't need to be remembered by the universe to have mattered. You don't need cosmic significance to justify your existence. You existed. You were aware. You experienced beauty and fear and love and wonder. That's enough. That's complete. Your legacy isn't in how long you're remembered, but in what you did with awareness while you had it. Did you create? Did you love? Did you help others experience beauty or reduce suffering or increase understanding? Those actions matter in the moment, regardless of whether they echo into the far future. The person you helped experienced that help immediately. The beauty you created was perceived immediately. The love you gave was felt immediately. Immediate mattering is real mattering. You don't need eternity to validate the present. And maybe, if humanity does become interstellar, if we do spread across the galaxy and persist for millions or billions of years, maybe your contribution to that trajectory, however small, however indirect, will be part of what made it possible, not because you'll be remembered individually, but because you were part of the collective human project, part of the species learning to survive in a dangerous universe, part of the bridge between what we were and what we might become. That's legacy enough. Being part of the process, contributing to the continuation of consciousness, of awareness, of the universe knowing itself through beings like you. The rogue black holes can't erase that. They can end individual worlds, individual civilizations, but they can't erase the fact that consciousness existed, that awareness occurred, that for a while the universe was looking at itself through your eyes and the eyes of billions of others. Let's think about eternity for a moment, but not the eternity of time, the eternity of the present. There's a sense in which now is eternal, not because it lasts forever, but because it's always now. The past was experienced as now when it occurred. The future will be experienced as now when it arrives. You never experience anything except in the eternal present. And in that present, rogue black holes are mostly abstract. They're concepts, ideas, mathematical models, possible futures. They're not immediate, not visceral, not part of your direct experience right now. What is part of your experience right now? What are you actually feeling, sensing, thinking in this moment? Probably not terror, probably not panic, maybe curiosity, maybe a kind of philosophical contemplation, maybe mild unease mixed with wonder. The present moment is almost always more manageable than the fears we project into it. When you're actually in danger, when a threat is immediate, your body responds automatically. Adrenaline, heightened awareness, fight or flight. But right now, there's no such response because there's no immediate threat. The rogue black holes are thought objects, not percept objects. They exist in your mind as ideas, not in your immediate environment as sensory presences, and ideas, no matter how frightening their content, can't hurt you the way physical threats can. They can disturb you, can make you uneasy, can occupy your attention. But they can't actually harm you unless you're in a situation where thinking about them prevents you from responding to immediate real dangers. Right now, thinking about rogue black holes is safe. It's an exercise in cosmic awareness, in contemplating the nature of the universe, in understanding threats that operate on scales far removed from your daily life. You can think about them without being harmed by them. You can understand the danger without being in danger. That's a gift of consciousness. The ability to model threats, to understand them, to contemplate them from safety. Other animals respond only to immediate dangers. You can think about dangers millions of years away and use that thinking to motivate long-term planning. But you can also release the thinking when it's served its purpose, when you've extracted the insights and motivation it provides, and return to the immediate, to the present, to what's actually happening now. And what's happening now is, you're safe, you're aware, you're here. The rogue black holes are there, somewhere in the galaxy, wandering, but there is not here, and that distance is everything. Let's bring this meditation to a close with a thought about courage. It takes courage to contemplate cosmic threats, to look at rogue black holes and asteroids and supernovae and all the ways the universe can harm us, and not look away, not deny, not pretend we're safer than we are. You've done that. You've spent time thinking about invisible predators, about objects that hunt through the galaxy without knowing or caring what they might destroy. That's not easy. It would be simpler to ignore these threats, to focus only on immediate, manageable dangers, to live as if the cosmos is stable and safe and will remain so forever. But you didn't choose simple. You chose to know, to understand, to confront the full reality of existing in a universe that contains dangers beyond your control. That's courageous. Not in the sense of physical bravery, you're not facing immediate danger, but in the sense of intellectual and emotional courage, the willingness to know difficult truths and integrate them into your worldview. And having done that, having confronted the fear and examined it and understood it, you can now choose how to live with that knowledge. You can choose fear, can let the awareness of rogue black holes make you anxious and small and focused on the dangers. Or you can choose engagement, can let the awareness motivate you to support space exploration and scientific research, and the long-term projects that might make humanity more resilient. Or you can choose acceptance, can acknowledge the danger, and then release it, trusting that either it won't materialize in any time frame relevant to you, or if it does, that future humans will deal with it as best they can. All three responses are valid. You might move between them at different times, but the point is, you get to choose. The danger doesn't determine your response, you do. And in that choice, in that agency, even in the face of threats you can't control, you find your power. Not the power to stop rogue black holes, but the power to decide what they mean to you, how much space they occupy in your awareness, how you live in a universe that contains them. That's real power. The power of consciousness to interpret, to assign meaning, to choose its relationship with reality. The rogue black holes are fixed. They exist, they wander, they threaten. But your response is flexible. You can be afraid or curious or accepting or determined or all of those at different moments. The universe doesn't tell you how to feel about it. You decide that for yourself. Rest now in that power, in the knowledge that you're conscious, aware, capable of choosing your relationship with cosmic dangers. The black holes hunt through the darkness, invisible and indifferent, and you observe them from here, from safety, from the warmth of a world that has harboured life for billions of years and might harbour it for billions more. Both things are true. Both things are real. The danger and the current safety, the cosmic threat and the immediate peace, hold both, accept both. And in holding them together, find the balance between awareness and presence, between planning and experiencing, between fear and wonder. You're alive in a universe that contains rogue black holes. That's a remarkable thing. Not comfortable, perhaps, but remarkable. And remarkability is worth more than comfort. It's worth more than false safety. It's the gift of consciousness, to know the universe as it actually is, dangers and beauty intertwined, and to find meaning not despite that truth but because of it. Sleep now, or wake, or continue your day, carrying this knowledge lightly. The rogue black holes are out there, and you're here, and that's how it should be. The universe is vast enough for both. The present is peaceful enough for rest. The future is open enough for possibility. Be at peace with the hunters in the dark. They're part of the cosmos that created you, part of the story you're in, part of the context that makes your existence meaningful. They're there, you're here, and for now, for this moment, that's enough. That's everything. The invisible predators wander, the conscious beings wonder, and in the space between wandering and wondering, life continues, awareness persists, and the universe knows itself through eyes that can see even what's invisible, can fear what's distant, and can find peace despite the dangers. Rest in that peace. The galaxy is large, time is long, and you are here now, aware, alive, part of the eternal present where all experience occurs. The rogue black holes cannot touch this moment, and this moment is all you ever really have. Be here. Be now. Be at peace with what you cannot control and engaged with what you can. That's the teaching of the invisible predators. Know the danger, respect it, and then live fully anyway. Live fully anyway. That's enough. That's everything.